So it's been a great period for the EDA industry. For Mentor Graphics, we just concluded 5 straight years of revenue and earnings growth, exceeding the growth of the industry, therefore gaining market share, and just set all-time records in revenue, in earnings per share, in our bookings, largely because of all of the dynamic things happening in the industry, and because we've had good steady growth of the semiconductor industry and strong growth of the systems industry as well. The EDA industry grows when the semiconductor industry requires new capabilities. One of the biggest discontinuities that occurred in the last few years was the move to emulation. So as microprocessors moved to multi-core, simulation was unable to increase its performance at the same rate as it had historically. And so more and more of the largest chips had to be verified with both emulation and simulation. And as a result, because customers were doing an emulation of the full chip, they also started doing emulation of the embedded blocks and then doing hardware-software co-verification. And as Mentor introduced test bench acceleration and virtual stimulus, it meant now that large server farms of emulators could be used remotely around the world, and we saw a major transition to emulation for leading edge users. But that wasn't the only thing that occurred. The introduction and move to 14-16 nanometer has created new physics problems. So programmable electrical rule checking now has become a key part of the traditional physical verification, for which Caliber is pretty much the de facto standard for the industry. So now checks of electrostatic discharge protection and voltage differentials and a whole variety of reliability checks are now required. At the same time, design for test has soared as an industry. It used to be a small part of EDA. Now it's one of the fastest growing parts because people need built-in self-test for automotive applications and for all sorts of other consumer equipment. But more importantly, the use of scan in new ways to have hierarchy and embedded IP and to be able to further compress test vectors to reduce test cost, but increase coverage, and most recently, the move to transistor level fault models to complement stuck at fault and transition models, something that will be mandatory as we move to FinFET technology and test moves another step forward. More and more people will use emulation. They'll use it because it's one more tool in the verification process. But the strange part is that simulation continues to grow and grow very rapidly, almost as rapidly as emulation, at least for Mentor Graphics. The reason? All sorts of new requirements for the simulators. The automatic generation of assertions, the use of formal methods, what we call push-button formal being integrated into the simulation flow, graph-based verification, a whole variety of coverage metrics, things that the simulators can do that have caused a growth in the amount of simulation-based verification, well integrated in an environment that also includes the emulation and the hardware-software co-verification. Is there a limit to the amount of verification you can do? I don't believe so. I think people will do as much verification as they possibly can, both with simulation and with emulation, in order to assure that components and systems do what they're supposed to do and do it correctly. Of course, Mentor grows primarily organically, developing our own products. But sometimes it makes most sense to do acquisitions. Oasis and Berkeley Design Automation were two opportunities for us to acquire best-in-class technology that complements what we already do. In the case of Oasis, Mentor has traditionally fit into flows by Cadence, Synopsys, and others so that customers could use synthesis from one supplier and other capabilities from Mentor. And we prided ourselves on open standards and our ability to integrate in those flows. But we found with Oasis that a company was able to produce dramatically superior results in logic synthesis, smaller area, better performance, and as a result, ultimately concluded that our customers could differentiate their designs by moving to a new paradigm that does the optimization at the RTL level, that allows an interaction with the floor planning function and the synthesis function to simply design better chips faster and to synthesize very large blocks of logic. In the case of Berkeley Design Automation, they are well known, not just in Israel, but around the world, as the leading high-performance analog and RF provider in the industry today. I believe we brought something to them in expanding their distribution and support network, but they brought a great deal to Mentor Graphics in putting us in a leading position for the capability in analog high-performance design, RF design, as well as mixed signal, and complementing the Eldo and Eldo Premier product lines, as well as the ADIT FastSpice from Mentor, giving us a full spectrum of products that are best in class and that can respond to the rapid growth of analog and RF requirements among customers around the world.